Okay, 14 is a proofs question. Proofs, there are three different types of sort of generic proofs, or disproofs, we should say. Um, there's one type which will prove that a statement is wrong, and that is a disproof by counterexample. So that's where you think of an example of maybe some numbers to substitute into something, or an example where something is wrong. Okay, and that comes up here. There's two types then which will prove something's correct. We'll come on to them in a moment. So 14 here. What I would say about this question is that there's not many proof questions out there. There's only one on the sample paper, and then there's this one here. They're very similar in style. They both have two statements that they give, A and B. One of them is wrong, one of them is right. You need to prove which one's wrong, which one's right. Okay, so that seems to be the style we're going for. So it says in each of the two statements below, C and D are real numbers. Obviously, we don't know what they are. They could be anything. One of those statements is true. The other one is false. And they give these two statements here. I'll come back to in a moment. A, identify the statement which is false. The only way you can do that, it actually tells you how to do it in the question. Show by counterexample that this statement is false. Okay, so we have to pick the one that is false and prove it is by picking a counterexample. Or in other words, picking some values of C and D that prove it to be wrong. So let's have a look at these two statements here. The first one, they're saying that this squared bracket here involving C and D comes out to be this. And in B, they're saying that this is equal to all of this. Now, my initial thought in terms of picking the one that is wrong is that this second one looks very complicated to prove by counterexample. Sure, you could do it and try some numbers, pick some numbers until we eventually get fed up of putting numbers into this because they'll always come out to be correct. But this one here, I know on my head what happens when we square a bracket, and it is not this. So that's my initial thought. Now, I know in my head that this one is the false one, question A, but I need to think of some examples. So for statement A, okay, I'm going to try, let's say C equals 2, D equals 3. This should prove that it is wrong. And I'm going to prove that when I put in 2 and 3 there, it's not going to give me the same answer as 2 and 3 there. Therefore, I would have proven that statement A is actually wrong. So if I put them in, then I get 2 times 2 minus 3 all squared. And I can tell you right now that that comes out to be 1. And then I can try the other one. Okay, so it's 4 times 1 squared, take away 3 squared, if I put them into this right-hand side here. And, or what did I say? 1, sorry, 2. So 2 squared is 4, 16, minus that, minus 9 is 7. Okay, therefore that is being proven wrong. Okay, if you want to just write a little thing that says that they're not equal or something like that, then go for it. Okay, but I think you should be enough to just show the workings that you have done to say which numbers you were substituting in, and then you've shown a couple of sums that give two incorrect answers, two different answers on either side. So that's the slightly easier part. Part B, identify the statement which is true. And obviously, part B is true. This one here. Give a proof to show that this statement is in fact true. Now, there's two ways at AS level, pure maths, to show whether a statement is true. It is proof by exhaustion or proof by deduction. Now, exhaustion is where you try every single possible number to prove, and it should work every single time. Now, that is not realistic with part B, because if you were to try every single number, you would be literally there forever. If it was proof by exhaustion, they would probably limit the numbers you're allowed to put in the question somewhere. Now, this means that it is going to have to be proof by deduction for part B. Now, proof by deduction is mostly algebraic. Now, what I'm going to have to do for part B here is I'm going to prove that when I actually expand these brackets on the right-hand side here, I get the left-hand side. So it's proving that it's the same on both sides. Now, so I'm just going to take the right-hand side, the complicated looking side with a load of brackets here, and I'm going to expand it, and I will end up with the same. I will end up with 8c cubed minus, sorry, d cubed if I expand this correctly. So when you expand a couple of brackets like these, where there's 2 terms in the first one and 3 terms in the second one, I'm going to take 2c and times it by all 3 things, and then I'm going to take minus d, and I'm going to times it by all 3 things. So 2c times 4c squared is 8c cubed. 2c times 2cd is 4c squared d. 2c, sorry, I should maybe list the sums that I'm doing, so I've done those two. And 2c times d squared is plus 2c d squared. Now I'm going to go on to the minus d. So minus d times 4c squared is minus 4c squared d. Minus d times this is minus 2c d squared. And minus d times this is minus d cubed. Hopefully you'll notice that cancel out, that cancel out, and you get ac cubed minus d cubed, which has proven by deduction that it's correct.